Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm super happy about this and I'm very glad that I was able to come up with my own solution to this problem without any help. So let's go over it and let me show you how I did it. So this is 3979 maximum valid pair sum. So you're given an integer array nums as usual, and you have this integer k that you're also given. And basically, you just want to find the maximum pair sum, so any unique pairs where the difference in the indexes are at least k or more. So let's first come up with the brute force approach. Let's get the length of nums, and let's just iterate through every single pair. And again, we can just ask at any point if the difference is bigger than or equal to k, then record the answer of the sum of those pairs, and if it's the max, then record it. And at the end, we can just return our answer. So this technically works, but it's an n squared solution. So if you look at the constraints here, 10 to the power of 5 means that n squared will not work. So let's think of a better solution, and let me show you how I optimized it. So you get time limit exceeded. Basically, the idea, if you want to keep a space of at least k, why don't we just scan through the array? First, for example, if we're on the current element, we're going to be caring about everything here and everything here, right? So why don't we just keep two sorted lists, one for the left side at least k away, one from the right side at least k away at each iteration, and find the maximum of the current pair and anything in those lists, right? Because that will keep everything in sorted order since we're trying to maximize this value. So basically, if we were on here, then there would be no right side and left side would be 1 and 3. And if we were here, left side would be 1, 3, and 5, no right side, right? So let's go ahead and do exactly that. Let's keep a left side and let's keep a right side, which is going to be sorted list as well. But we're starting from k to the end, right? Because we only care about everything up to k, and we're going to basically in each turn, if we're going here, we're going to discard any element that is exactly k minus 1 away so that we keep it at least k distance away from the current element. So this would be the right side if we were on index 1 with the value of 3, and there would be no left side, and then here we would insert a left side value. Okay, so let's go ahead and loop through nums again, and this time if I plus k is less than n, then we can basically discard nums of I plus k. So let's go ahead and print I and right just to verify we're doing this correctly. So if we're at 0, 2, and 8, so this is actually incorrect. You can see we do not want to discard, so let's actually start at k minus 1. So if we're on 1, then we want 2, 3, and 8, or if we're on 0, 2, 3, and 8, this still doesn't look correct, so let's actually try minus 1, and basically just play around with it a little bit. So 2, 5, 8, perfect if we're on index 0, index 1, 2, 8. And then the same thing with the left side, right? If I minus k is bigger than or equal to 0, then that's exactly k or more to the left of the current value, 5 being the first. And then we can just add nums of I minus k. So let's go ahead and print I and left and right just to make sure this looks correct. So you can see here, there should be for 5, which is index 2, there should be 1 and 8. Perfect. So now what we would do is just take the current value, right? If there is a left side, then the current value and the biggest in the left side, which is just the -1th index, because this is a sorted list. So we would take the max of answer and left of -1 plus the current value. This is the index. So if right, we do the same thing, plus the current value. And then at the end, we can just return the answer, right? But there might actually be another edge case. In this case, I guess not, where we only take left and the right, but I guess that doesn't count because anything on the right will already have been processed at a certain point before that element is inserted into the left-hand side sorted list, right? Okay, let's submit it. And there you go, passes all test cases. So again, I'm super happy that I was able to solve this question completely on my own without any help. So yep, that's it for this video, and thank you for watching.